We can also solve a system of equations using elimination. The goal here is very similar to what we did with substitution, in the sense that we are going to reduce this system down to a single equation with one variable. All that changes is the process of how we get rid of that other variable. In the previous examples, it was pretty straightforward to use substitution because we always had at least one equation that was set equal to y, that was already solved for y. When we look at examples 8 and beyond, in each of these cases, they're written in standard form, so they're not solved for x or y. If we could use substitution to solve these systems, but the first thing we'd have to do is solve one of those systems for either x or y before we could make that substitution. It would absolutely work. But what tends to work better in these cases is to use this other approach, which is called elimination, so that we have a little bit less algebra that we have to take care of. When we look at using elimination to solve a system, what we want to do is add the two equations together in a way that one of the variables completely cancels out. Example 8 is already set up nicely to do that. If we add these two equations together, we get negative 2x plus 2x cancels, leaving us with 0x. And then we get 4y minus 3y. So we end up with plus 1y or plus y is equal to 23. Again, this one was intentionally set up nicely, so we could just add those two equations together without doing any other work. When we get to the next few examples, we'll have to do a little bit more work to get one of those variables to cancel. But this is the general idea. Add the two equations so that one of the variables cancel, and what we're left with is an equation in just one variable. In this case, there's no coefficient in front of y, or 1, I guess, is the only coefficient. So this is already solved for y, and we have half of the solution to our coordinate pair. From there, we take that and plug it back into either of the original two equations. We'll use equation 1, so we'll rewrite this as negative 2x plus 4 times, in place of y, we'll substitute in 23, is equal to 22, and then we'll solve for x from there. This will give us negative 2x plus 92 is equal to 22. We'll subtract 92 from both sides to get negative 2x is equal to negative 70, and then dividing both sides by negative 2 will give us positive 35. So we have the coordinate pair 35, comma 23. The key step in these, again, just like we did with substitution, is to start off with a system of two equations and two variables, but then reduce that down to a system with to reduce that down to just a single equation, no longer a system, with only one variable that's relatively easy to solve for.